In this lesson, we're going to discuss polynomials. So first, let's talk about what a polynomial is. And a polynomial is an expression that's in the form a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus, and then you have terms in between, and it goes all the way down to a1 x to the first plus a0. Now the a's are the coefficients of the x's. An, because it's the very first term out in front when it's in descending order, is called the leading coefficient. So if you put all your x's in order from the largest exponent down to the smallest, that an that goes with the x with the largest exponent, that's what's called the leading coefficient. Now, the n's are the exponents, and in order for this to be considered a polynomial, the exponents have to be something that is a whole number. In other words, you can't have exponents that are fractions or square roots or decimals. The exponents have to be a whole number, meaning 0, 1, 2, 3, 4, etc. Now, you can have exponents that are rational numbers or square roots. However, then it would not be considered a polynomial. Now, the largest value of n the biggest exponent for x, which is your n, is called the degree of the polynomial. And for right now, you just need to be able to identify what the degree is. That's your value of n. But in subsequent classes, if you have to go on to take higher level math, what you're going to find is the reason why it's important to identify what that n is, if you're going to go to actually graph the polynomial, that n will help you determine the shape of the graph. Okay, now there are different kinds of polynomials, and they're based on the number of terms that they have in the polynomial. And there are three common types of polynomials: a monomial, which is a polynomial that has one term. Then we have what's called a binomial, which has two terms. And then we have a trinomial, which has three terms. Okay, so looking at example A, we're going to identify which of the three common types of polynomials these are. And just for practice also, let's identify the leading coefficient and the degree as well. So when I look at 3x minus 4x squared plus 5, if I put it in what's called descending order, that means we're going to list the term that has the highest exponent for x first down to the term with the lowest exponent for x. So if I rearrange this in descending order, that would give me minus 4x squared. Because 2 is the largest exponent, the term with 2 would have to come first. Then plus 3x, and then plus 5. So this is what's called descending order. When it's in descending order, it's easier to identify what your leading coefficient is. And I'm going to abbreviate LC for leading coefficient. Your leading coefficient is the number that's in front. I know it's kind of immature to think of it this way, but it kind of helps remember. But I think of it as the engine of the train because it's right in front. So my leading coefficient is -4. My degree of the polynomial is the largest exponent for x. And in this case, my largest exponent for x is 2. So I would say that this has a degree 2. And now we can also identify that this is a common polynomial because if you notice, I've got one term, I've got two terms, and then I've got a third term here. And terms are separated by pluses and minuses. Just to do a quick review of vocabulary, factors are separated by multiplication, and terms is separated by addition and subtraction. So we've got 3 terms here, which means this polynomial is specifically the common polynomial called trinomial. Okay, looking at the next example, 5y to the third. There's only one term here, so I don't have to put it in descending order. My leading coefficient by default would be 5, and my degree by default would be 3 because we only have one term here. And because we only have one term, this would be considered a monomial. And in example C, this is already in descending order because I have 2y. Even though we don't write it in there, we know it's 2y to the power of 1 minus 4. Even though we don't write our exponent in there for y in the last term, we can actually rewrite it as y to the 0 power because we know, remember, y to the 0 is equal to 1. So my leading coefficient here is 2, and my degree is 1. And because this has 2 terms, this is considered a binomial. Okay, when we want to add and subtract polynomials, really all we're going to do is we're going to combine like terms. So I have a binomial. I know it's a binomial because it has 2 terms, and I'm adding it to another binomial. Because this is a +1 in front here, I can just remove the parentheses because if I distribute that 1, I'm still going to have -6y plus 2. So if I have 4y plus 3, and then I'm adding a -6y plus 2, all I'm going to do is combine like terms. So I have a 4y and a -6y. That's going to give me a -2y. And then I have a 3 plus a 2. That gives me a 5. Just to practice, my answer is a binomial because I have 2 terms. My leading coefficient is -2. And my degree is 1 because my largest exponent for y, even though it's not written in there, my largest exponent is 1. Okay, the second example in B, notice I have a subtraction here, and even though we don't write it in there, it's times -1 on the outside. So I have 2a squared minus a. In order to remove those parentheses, I have to distribute that -1. So I have a -1 times 8a, which gives me -8a, and then I have a -1 times the 4, which gives me a -4. I see a lot of students make the mistake that they just remove the parentheses and they forget to distribute that minus. So you're subtracting everything that's on the inside of the parentheses because that -1 is in front of the parentheses. So don't forget to do that. Now we're going to combine like terms. I don't have any other a squares, so I'm just going to carry down the a squared. But I can combine the -a and the -8a as the -9a. And then I don't have another constant to combine with the minus 4, so I'm just going to pull that down. Now this is in descending order because I have the largest exponent for a first, down to the lowest exponent for a. Remember, even though we don't put it in here, this is like saying a to the 0 power. And so this polynomial is a trinomial because I have 1, 2, 3 terms. My degree is 2 because that's my largest exponent for a, and then my leading coefficient is 2. Okay, and example C, the only thing we can combine here is the negative 6xy and the positive 9xy. So I'm going to carry down the 9x squared, and I have a minus 6xy plus a 9xy. That's going to give me a 3xy minus 6y squared. Now, just a thought, if it was written like this, where the x and the y here are swapped, those are still considered like terms because remember with multiplication, the order doesn't matter. Right? 3 times 2 is still the same thing as 2 times 3. So if it's multiplication and the order is switched with the variables, as long as it's the same variables with the same exponents, they're still considered like terms. Okay, and then in the last example for practicing addition and subtraction and combining like terms, we have another subtraction problem where I have a trinomial, because I have 3 terms, and I'm subtracting another trinomial. Because I'm subtracting the entire polynomial 3x squared minus x plus 4, I have to remember to distribute that minus 1. So I have 4x squared minus x plus 1, and I'm going to subtract 3x squared. I'm going to subtract a negative x, which gives me a positive x, and I'm going to subtract 4, which gives me minus 4. And now I combine like terms. I have 4x squared and a minus 3x squared. That gives me x squared. I have a negative x and a positive x. That adds to give me 0, so I have no more x's. If you want, you can write it in there, but you don't have to. And then I can combine the 1 and the negative 4. That gives me a negative 3. So my final answer, because I have 2 terms, this is considered a binomial, and my leading coefficient is 1. My degree is 2. When I multiply polynomials, we're going to have to use exponent rules because we're going to be multiplying variables with the same base. So if I want to take 2a times 5a squared plus a minus 1, I'm multiplying a monomial because I have the 2a as one term. That's a monomial, and I'm multiplying it by a trinomial. And we have to distribute and multiply that 2a by everything that's on the inside of the parentheses. So I'm going to take 2a times 5a squared. That's going to give me 10a cubed because I multiply the 2 times the 5. And when I multiply the a times the a squared, since we're multiplying and the bases are the same, I add my exponents. That gives me a 1 and a 2, which gives me a total of 3 for my exponent. Then I take the 2a times the a. So I multiply my coefficients. My coefficients are 2 and 1, so that gives me a 2. And when I take the a times the a, that gives me a squared because I add the 2 1s for the exponents. And then I take 2a times a negative 1, and that gives me negative 2a. So my answer is going to be a trinomial with a leading coefficient of 10 and a degree of 3. We're doing the same thing in example B. I have a monomial because it's one term, and I'm multiplying it by a trinomial that has 3 terms. So I'm going to take 3a to the third, b to the third, and multiply it by each of the terms that are inside the parentheses. So you multiply your coefficients together, and then you combine your like bases using the product rule. So I have 3 times 2, which is 6. I have a to the third times a squared. That's going to give me a to the fifth because I have to add my exponents. And then I'm left with a b to the third. Now I'm going to take 3 times negative 4, that gives me a minus 12. A to the third times a gives me a to the fourth. And then b to the third times b gives me b to the fourth. So 3a to the third, b to the third, times the middle term, which is minus 4ab, gives me negative 12, a to the fourth, b to the fourth. Now I have to take 3a to the third, b to the third, and multiply it by the last term. It's going to give me a negative 6. There's no a in there to combine it with, no base a, so I'm going to just bring over the a to the third. And then I have b to the third times b squared, which gives me b to the fifth. Now, when we're multiplying and we have something other than a binomial, we have to use the distributive property. So I'm taking a binomial times a binomial. So I have to take a times a minus 4, and then 3 times a minus 4. I have to take the a times everything in the parentheses with the a minus 4, and then take the 3 times everything in the parentheses with the a minus 4. So a times a is a squared, and then a times minus 4 is minus 4a. Then I take 3 times a, which is 3a, and 3 times the negative 4 is a negative 12. And then I combine my like terms. And the only terms here that I have that are alike are the a's. So I'm going to copy over the a squared. I'm going to combine the minus 4a and the 3a. That gives me a minus a. And then bring down the minus 12. Example D, same thing. We've got a binomial times a binomial. So I'm going to take 4x times 4x. That gives me 16x squared. Then I'm going to take 4x times 3. That gives me 12x. Then I'm going to take 5 times 4x. That gives me 20x. And then 5 times 3, which gives me 15. And then I combine my like terms. And my like terms here are the x's. So I'm going to carry over the 16x squared, and I'm going to combine the 12x and the 20x. And that's going to give me a 32x. And then bring down the 15. Okay, example E, we have x to the third minus 5 times y to the fourth plus 4. So I'm going to take x to the third times y to the fourth. Now those bases I can't combine because they're different. So I'm just going to leave it as x to the third y to the fourth. And x to the third times 4, which gives me 4x to the third. And then minus 5 times y to the fourth gives me minus 5y to the fourth. And then minus 5 times 4 gives me a negative 20. Now here I have no like terms that I can combine. So at this point, I'm just done. I stop here. Now the very last example in this lesson, I wanted to make a big deal about this because this is a common mistake that a lot of students make. So I'm going to make my mistake in red. I'm going to purposely make a mistake. So this is not correct in red. This is a common mistake. So we have 5a plus 3b squared. And when students see 5a plus 3b squared, they think of exponent rules and they think they have to take everything that's on the inside and square it. So they would write it as 25a squared plus 9b squared. However, that is not correct because you have an addition sign in here. Previously, when we talked about squaring things on the inside and you take everything that's on the inside and square it, that would be the case if I had something like this. Notice that there's no addition or subtraction sign in here. It's just one term. So I take the 5 and square it, which gives me 25. I would take the a and square it and get a squared, and I take the b and square it and get b squared. Because this is the same thing as saying 5ab times 5ab. When you square something, you're multiplying it twice. So when we take 5a plus 3b and square it, whatever's inside here, we have to multiply it twice. So that's the same thing as saying 5a plus 3b times 5a plus 3b. So by doing it this way, the incorrect way, what's going to happen is you're going to miss that middle term when you FOIL. So doing it the correct way, I'll label this as correct. You take the 5a times the 5a, which is the 25a squared. Then 5a times 3b, that gives me 15ab. And then you take the 3b times the 5a, that gives you 15ab again. And then you take the 3b times the 3b, and you get 9b squared. And when you combine your like terms, you get 15ab plus 15ab, which is 30ab, and bring down the 9b squared. So this is the correct answer to 5a plus 3b squared, because whenever you're squaring something, you have to multiply it twice. If you take this shortcut here that is incorrect, what's happening is you're missing that middle term, that 30ab in the middle. So make sure when you're squaring something, if you're not sure if you just square everything on the inside, or if you have to FOIL it, just write it out. Whatever's inside the parentheses, multiply it twice, and that will remind you what you need to do. If you need to FOIL, or if you just need to combine your bases using the product rule.